Thank you very much for joining us today at this session on using machine learning to forecast and understand force displacement. My name is Alexander Kjaerum. I'm a senior analyst and global advisor with the Danish Refugee Council. And I'll present today together with Kjaerum from Kjaerum. We'll show two different examples of how we've used and applied machine learning to forecast displacement. I'll go first and present on this Foresight project we have worked on, and I'll be presenting for around 20 minutes. Then Kjaerum will introduce to the model that he's been working on and they've been working on, and will also take around 20 minutes. And then we'll have 20 minutes in the end of the session for a Q&A. I suggest that you already now, if you have questions, you're welcome to write them in the chat. Maybe some of them we can easily address as we go along in the presentation, and otherwise we'll of course address them in the end of this session. But again, thank you very much for joining us. I see we have more than 35 participants now, so that's great. I'll go ahead and just share my screen, and I hope you can all see it. And as mentioned, I'll present on this Foresight project. I work in the Danish Refugee Council, and my role is to really support our organization with becoming even better at using data and analytics to inform our work. And as part of this, we 3 years ago set out to sort of explore the use of predictive analytics. We entered into a partnership with IBM and received funding from the Danish Ministry of Foreign Affairs to really explore what is the potential of predictive analytics and how can this inform our work. And this was built a little bit around also recognizing the failure in our organization, but I think also potentially in the wider humanitarian system to foresee some of these major humanitarian crises, the so-called European refugee crisis, the Rohingya crisis in 2017, and so on. And despite the fact that we have a lot of data in our sector, we seemingly were not becoming better at foreseeing these events unfolding. So what we set out to do was to see if we could build a machine learning model that could forecast force displacement 1 to 3 years into the future. Initially testing it out in Myanmar and Afghanistan, but with the ambition of rolling it out to more countries. And the idea was really if we could have such a model that it could assist our organization in our annual sort of strategic planning cycle, but potentially also be used to inform the wider humanitarian sector for sort of strategic planning purposes. And the model we built was designed around sort of a framework that looks at your typical drivers of displacement. So we are looking at sort of the macro level, the typical sort of root causes of displacement. So it's violence levels, it's the economy, it's governance aspects, aspects related to the environment and climate, and of course also population composition. And we use more than 120 different indicators in our model to measure these different dimensions. Now we know from the design of this framework that it isn't a perfect model. We're not looking into sort of what you would call mediating factors. So of course, the cost of movement, border policy regimes, and so on, they will impact on displacement dynamics. But we're not taking that into account in this model, simply because a lot of it is quite difficult to measure and quantify. And of course, we need numbers to put into our model. The other aspect we're not looking at is the more sort of micro level, household level aspects, which again also, of course, impact on displacement. That could be perception of security and issues like that. And the data that we use in our model is all drawn from open sources. Typically, the data that we look at is at sort of an aggregate national level, most of it is updated on an annual basis, and the data sets typically have global coverage. And so a lot of the data we use is taken from the World Bank development indicators. We use conflict data from ACLED and Uppsala. We use other data points from different UN agencies and so on, but generally sort of reputable sources. And we put that into sort of the black box. I will not go too much into detail. That's sort of beyond me, unfortunately, on this machine learning algorithm. But essentially, what it does is that we put 25 years of historical data on all these indicators, and the model essentially learns from the patterns and relationships in this data, and on the basis of that, predict what will happen in the future. And we work with actually two different models in this project. One is this sort of point forecast model, which essentially gives you a number of what will the stock of displaced people be from a given country 1 to 3 years into the future. Now, the other model we also have developed is this sort of Bayesian network model, which looks at a sort of a subset of 15 of the key drivers of displacement, and looks at what is the relationship between these different drivers of displacement to really understand that sort of network that drives displacement risks. And all this is captured in an online user interface where users can go in, they can play around with access to forecasting, they can play around with the model and build their own scenarios and so on. And I'll introduce this more in detail now in the presentation. So, as I mentioned, we tested it out in Afghanistan and Myanmar, and it really sort of showed encouraging results. And so basically what you're seeing here, the red dots were the actual displacement stock that year, and the green squares or diamonds were the predictions that our Foresight model made. So essentially what we did to evaluate how accurate is this model, we gave the model data up until 2009 and then asked it to predict 2010. Obviously, we know how many people were displaced in these countries in 2010, so that way we can calculate with the error margin for each year. And if we take the average across all these years, we get an average margin of error down to 8% in the case of Afghanistan and 9% in the case of Myanmar. And that we sort of consider to be sort of a fairly good and accurate result that you can actually use to base decision of in terms of your strategic planning. But we also notice, I would say, two key limitations in this approach, and I think especially highlighted in the Myanmar model. And I think one aspect is that the model has a hard time predicting unprecedented events. And this, of course, goes to the methodology that when you base your model on historical patterns and relationships, the ability to predict or forecast something that hasn't happened before is very difficult for these type of models. So it tends to be conservative. And as you see, sort of the Rohingya crisis in 2017, the model didn't come close to predicting that. And you could say that's also very important limitation, because it's, of course, especially in those situations that you would like these models to actually be able to forecast the more sort of unforeseen events. The other challenge or limitation in our approach is, and that also helps explain a little bit why we were not predicting the Rohingya crisis, is that the model tends to perform better in countries where the displacement situation is more widespread. So because we built the model around national level data, when you have displacement situations that are fairly regionally confined, the model has a harder time predicting those trends. If we look at our national level data from Myanmar in the run-up to the Rohingya crisis, and actually also in that year, a lot of things were going great in Myanmar, seen from a national level perspective. Governance were improving, democracy aspects were improving. Actually, violence levels nationally were not as high as they'd been in preceding years in 2016 and 17 and so on. Of course, the situation in Rakhine State was very different from what was happening nationally in Myanmar, but that didn't really sort of translate into the national level data that we were looking at. And I'll get a little bit more into later also what we're doing to try to correct and address for these things. Now, after these sort of initially sort of encouraging results, despite the limitations, we have now included more than 20 countries in the model, or applied the model in 20 countries. And again, because we built it around these global data sets, that's been fairly easy because we can use the same indicators and same data for each of the different countries. And what we can see is, of course, 8-9%, is that good or bad? And there are different ways you can benchmark that. One way we have tried to benchmark it is to say, well, what else is out there? What is currently being used in the humanitarian sector for the strategic planning? And of course, as you may know, one of the key elements in the humanitarian sector are the humanitarian response plans, which are being developed each year in the different humanitarian crises, where there are planning figures about what will the caseload be for the coming year. So what we did was to try to analyze, well, how accurate are the planning figures in these humanitarian response plans compared to what our model is, how that is performing. And we can see that actually in most of the cases, in most of the countries where we have applied and where we can compare the results, our model tends to be more accurate. There are a few exceptions, which are Somalia, Chad, Libya, and Venezuela. And again, there are still some work in terms of adding country-specific data to the models and so on. So we also believe that we can actually get our margin of error down on a number of these in a number of these countries, and there may also be able then to outperform the humanitarian response plans. Now, as I mentioned, we also developed this network model, and the reason why we developed it was because we recognize sort of the limitations in our approach. I think the way we're suggesting to use it and the way we're using it internally in the Danish Refugee Council is that it's the forecasts are a good starting point, but we really also encourage that it's used also more for scenario building exercises, where we can take into account the expertise from our staff in the specific country offices. They can inform us on developments on the ground, and we can factor that into the model, and then it can give you a scenario-based forecast of displacement. And to inform that sort of scenario building, we thought it would be good to have a sort of separate model that can help really understand how are these different elements linked. So we of course know that violence drives displacement, but violence doesn't only drive displacement directly. Violence also impacts on human rights. It also impacts on the economy and so on. These elements in turn also drive displacement. So really to understand how do all these different links work, that was why we developed this network model. This we didn't develop for a specific country, but made sort of a generic model based on data from 28 countries. And what this model can do is it can tell you if there's a change in violence, how will that affect the other elements in this network, the risk of having a bad human rights situation, for example, and then in turn give you a risk of different displacement levels based on those changes. So it can really help to inform that scenario building exercise by highlighting how these different elements work together to drive displacement risks. And as I mentioned, all this is captured in an online user interface. You're welcome to write in the chat if you would like to get access to this platform. You can also send me an email after this presentation, and then I can add you as users. I'll make sure to share my email address in the chat as well. And basically what you can do here, you can see the forecast the model is producing. You can build your own scenarios and see what happens if conflict increases a lot. How does that change the forecast? And then you can also access all the underlying data. So it also works a little bit like a curated database of displacement relevant data. So instead of you having to go to 18 different databases and websites, we've collected it all in one place for you, where you can download the data, you can make your own graphs and visualizations and so on. And to sort of make sure that we were on the right track with this work, we actually entered into a sort of a partnership with the OCHA Center for Humanitarian Data that have set up this peer review mechanism. And we were, I think, the first organization to actually go through that process, where we had sort of got validation that this model was actually quite useful. There were, of course, a number of recommendations of how we could improve it and make it more operational for the humanitarian sector at large. And just to give you sort of a few examples of, well, how this is all nice and dandy, and we can have these models in our computers, but of course, importance is, do we actually use it? We've used it in the Danish Refugee Council to inform a number of our annual strategic planning sessions last year, when the model was just finished before the summer last year. So we used it a lot in West Africa, working with our country offices there. And the way we also envision it going forward is not only to support our country offices, but also sort of more for global decision-making purposes. Again, the advantage of this model is that you actually apply the same methodology across a number of different countries, so you can actually sort of compare a little bit and combine the different country-specific models into a more general picture. This is what I'm showing you now. Here's just an example of what our model now is predicting, and in these 20 countries where it's been applied, it's predicting an increase of around 3.5 million in displacement stock here by the end of 2021. You will see that some notable examples is, for example, DR Congo, where it's projecting a significant increase in displacement this year. Another example is for these sort of more scenario-based forecasts, where we made an analysis of Afghanistan. We got reports of potential drought and increased conflict in Afghanistan. So we tried to look in what would this mean. We made some assumptions about how, of course, the context will unfold in Afghanistan, and based on that, we came up with a new forecast which suggested that for almost 500,000 more people would be displaced in 2021 compared to 2020 numbers. And going forward, we are of course applying this model in DRC, but are very interested in also working with external partners on using it and seeing if it can inform also other actors in the humanitarian system. Some of the feedback we've been getting internally as well as externally has been that this is quite useful for these sort of more annual sort of national level strategic planning sessions, but it would be interesting to also explore more operational models. And for that, you would need more information on where sort of more locally are displacement happening, also shorter time horizons, 3-6 months forecast and so on. So that is one of the things we're working on now, is to develop these more sort of sub-national forecasting models. Right now, actually working on a model in the Liptako-Goma triangle in the Sahel region to sort of forecast the number of IDPs at the admin 1 level, sort of 3 to 6 months into the future. And there will also, of course, be continued work on refining the existing model, adding more country-specific data and subnational data to this model, so it becomes also performing better in those contexts where the displacement situation is more regionally confined. One of the other aspects we're looking at, especially to support the sort of the subnational modeling, because at the subnational level we often lack access to data. So one of the things we're looking at there is the potential use of satellite imagery to cover some of these data gaps. And then, as I mentioned, we are then also just looking to establish relevant partnerships to really explore what is the potential use of this tool. We have, of course, have our vision of what it can be used for, but there can also be other use cases that we may not necessarily be aware of. Some of the discussions we've been having have related to, for example, anticipatory financing mechanisms and so on. So if you have any good ideas, again, feel free to reach out to me after this session. But I think I will stop there and look forward to if you have any questions or comments that we can address later. And of course, also feel free to just send me an email and then we can continue the conversation. But I will hand it over now to Yadet Kurisa from Kjaerum in Ethiopia. Thank you. You are muted, Yadet.
Do you hear me now?
Yes.
Okay, and my slides are on? Okay, yeah, thank you so much for the discussion, for your presentation, which really go hand in hand with our effort to address your last point, which is, making displacement, forecasting displacement at subnational level. So one of the difference or one of the overlap difference between our work and your work is that we are looking into the subnational forecasting challenge, and we have seen the global and country level prediction from your work. So first thing first, let me acknowledge our funding agency. This material is based upon work supported by the Defense Advanced Research Project Agency and the Army Office, ARO, under contract number described as in the slide. So in my presentation, because this is a practitioner workshop, I will focus on making hands-on exercise in terms of how to present a use case of forecasting for self-displacement by taking Ethiopia as a case study, and we will discuss why we are going to the motivation behind this project, and the whole data science workflow, which is data acquisition, analysis, and modeling. By modeling, there are sub-steps. We have to have feature engineering, training and testing, and finally forecasting. So I believe after all this discussion, we are going to learn the detail of the data analysis and the modeling part. So this session is basically, the objective is to introduce the application of data science and machine learning in peace building areas, to highlight key steps and procedure in applying machine learning for peace building, and to familiarize ourselves in what are the major tools and packages available to do this task of important endeavor. So this is the work done by Kjaerum. Kjaerum is a leading international organization, technology firm established in 2016, and we have done several projects since then, over 50 countries that are focused on resilience building, modeling, and sophisticated quantitative analysis, including surveys in these countries. We have offices in Ethiopia, Kenya, and we are headquartered here in the US. Our DARPA model, modelers initiative is, DARPA contracted Chemetrica about a year and a half ago to participate in innovative research of modeling key trends in East Africa, such as on conflict, population, and economic trends affecting those countries. So we are developing models around those indicators and partnering with a range of organizations back home and internationally. So why are we interested to do forced displacement? As Alexander was mentioning, now we are having close to 80 million, 70 million people of displaced stock around the world because of many reasons, primarily because of conflict and climate change. And we have seen over 40 million newly displaced population over year-to-year basis. So it's important to provide, highlight insights and modeling future displacement for humanitarian purposes. So for decision making, it's very useful activity. So we are taking a predictive model to forecast 1 quarter ahead of time, and at subnational level, as I was mentioning. So our target variable, what we would like to model to predict is that it is % of displaced population in current quarter, and this is using previous quarter data. So we are going to predict what is the proportion of displaced population in the future, as well as like one quarter ahead of time using current and previous history of other indicators. So here we are using IDP stock and survey data from IOM Ethiopia. So IOM has displacement matrix tracking effort in many countries in East Africa, as well as in many other parts of the world. So this is for Ethiopia now. It has reached 23 rounds of surveys. So in 11 regions across almost all parts of the country. And based on that effort, the displacement stock in the database has reached around 2 million people. And this is like 61% of the population is displaced due to conflict, and another 20% of the population is displaced due to drought. So this effort has been started from late 2017, and now the latest round of survey we have is January 21st. So having a clean, accurate displacement data is very important, and many studies have been trying to use remote sensing, artificial intelligence, and other techniques to drive displacement numbers, and we base ourselves in survey of IOM data, which is openly available from their site. And now the important thing is how to arrive at a newly number of displaced population per quarter across the country. So to do that, we calculated the difference between the displacement stock every rounds of surveys, and then we tried to model that number. Now, what is our conceptual or mental model is that we are seeing the decision to flee is based on 5 drivers of displacement, which can be categorized under political, natural, human, social, and financial stressors. So, for instance, under political um, driver, we have conflict, lack of freedom and discrimination in the country. And under natural or physical environment, we have climate change, drought, food insecurity, and so on. So under each of these categories, we have stressors that are making people to decide to leave their residence or their living area. And the decision also affected by costs like distance and geography and technology and the mobility situation in the country. So all in all, we are kind of trying to capture these indicators into our model and simulate the decision to flee. Okay, now let's go to the fun exercise, which is modeling work. The first thing is to import all necessary Python package. Here you have to have package such as pandas for data management and processing. For mapping, we have to have GeoPandas and GeoViews. And the important thing is the model is based on a machine learning, random forest machine learning model. We have to use that package. And to exploratory description, we need charts. For this, there are tools like Altair, Bokeh, and Seaboard. So these are the main tools that I used. And this is how you import all the necessary package. And the next step is to import the dataset, the clean and final dataset. Here we have a range of input variables, location, conflict from ACLED, all the data set mentioned during the earlier presentation, we kind of used at lower level here. So we have drought, we have rainfall, we have settlement trends, which is very important. The pressure on our physical land, the land cover and so on. We have population density, which is another important drivers of displacement, where when people, when the land is going to be densely populated and, stressors happen together with the population density, we expect, a number of people living from that area. All these variables along with the displacement, the proportion of displacement are serving as our model input features. So now quickly look at our target variable and input features. Our target variable is new displacement per quarter by region. Here you can see displacement trends in the country, where especially in recent years, in relation to the administrative change in Ethiopia, there is conflict spreading across the country, and we see a number of close to 200,000 people have been displaced in the last quarter of 2018, where that coincides with the coming of new administration, and then since then also continuously people have been displaced due to conflict, drought, and other issues, including flood, seasonal floods. So this is also by region, where you can see Oromia, the central and western and southern parts of the country is highly affected by conflict. There is huge number of displaced population, followed by Somalia. So this is historical, and for your information, currently there is a conflict in northern Ethiopia. which really is not included in this data set because the data set starts from late 2000, 2020. So the historical data does not capture the recent uh, conflict. Now we let's see quickly the features, the input features. So these are like conflict, number of fatalities, drought, rainfall, settlement range, all those indicators that I mentioned. The total number of count records is 201, and then you can see the mean values where there is 12 uh, loss of life per conflict event, where you see high value of drought index, where there is a small number of rainfall, where there is huge number of settlement disruption, where there is huge um, population density, name it whatever stressor, this is worst in affected areas. So um, you have all the indicators here. So the next step is to inspect if there is correlation between input variables, because this is an important step where you kind of avoid overfitting or multicollinearity in the model, because whenever there is correlation between two input variables, then that would be an issue in your model. So it will reduce the quality of prediction. So we have to kind of see the correlation between the variables. So for instance, conflict-related variables are highly related to one another. So we have to drop and pick up the best predictor of displacement. So you can see here some of the highly correlated variables, and then this is how we cleaned the data, and you can see the final selected variables where there is low correlation between each of the input variables. So drought index with population, for instance, is low, and every indicator's correlation is kept as minimum as possible to get quality forecast. So what are the final input variables? Number one is drought, and we have rainfall. Rainfall would help us to kind of capture the seasonal floods, which is also important, making in huge number of displaced population, particularly in river banks. And we have drought, which is also another very important indicator, where it makes the farming community to leave their places whenever there is drought. We have settlement range, population density, the onset of conflict, and all the remaining are related to conflict, which is the proximity between different conflict events. So the important thing is here, the data is obtained from open sources, um, such as NASA database, world population, uh, and ACLED dataset. ACLED is um, serving as an important source of conflict information these days. We are using extensively. To recently, there are changes in the policy of data use. Previously, it was easily accessed, openly accessed, but now there are some kind of restriction. Uh, so I hope there would be uh, way out to that, but we are benefited out of open source at large in any way. So the important thing about this is using open source, we can make useful analysis and modeling for that can serve countries, affected countries. Now, the model is mixed effect random forest. It's a machine learning model, and it's a kind of imitating the mixed effect, random model of parametric estimates, where you introduce a kind of cluster variation. By cluster here, I mean is variation between locations. For instance, if a different location has specific idiosyncrasy in those areas. For instance, a given area is highly affected or vulnerable in drought, then this randomness will help to capture that difference. And this is input variables, x, i's are input variables. Now the setup is in such a way that you predict current, using current information, you can predict next or next round of quarter. So this one is prediction for new cluster. As I said, this one is current x, I variables, and this is future displacement. So the important thing here also is how you would ensure the quality of prediction. Here we use root mean square error, where you would compare the actual versus predicted values, and then take the square root of that. It's called root mean square error, and as the lowest possible estimate would be advantageous in this case. The next step is you have the data, you split to training and test sets so that you can train the model and then test the performance before going to prediction. So train test split is based on probability. Entirely it's based on probability, where you took 20% of the data to test, and the rest of 60% for training. So using the 60% data, you are going to train the model, where simply using the mixed effect random forest model, you fit the model to the training information variables, and you have the outcome of the variable. So it can learn from these two using the random forest iteration. So the next step, once the data is learned using the actual training set and input set, you are going to predict. So using the models, this is the model that is learned, and then you predict using the features, the test features. So here you don't have any actual values. So you only provide the test set, the axis. So the model will spits out the predicted values. So this is the prediction stage, and then using the values that you predicted, you evaluate the actual versus the training set. So evaluation here, as I said, is using root mean square error. Our root mean square error is very, very low. It's around 0.5%. And we have R score, which is how the input variables are explaining the output, is about 71%, which is also pretty good. Now, the next step is to visualize the model output. You can map, you can do some descriptive analysis. Here we have mapped the actual displaced population. versus the predicted number of displaced population, where you can see almost similar trend in both actual and predicted values. So this is the output of the training and test set. Next step is you also can identify what is the important variables contributing in this prediction. So we can reflect on what are the main important variables that led to the good prediction here. As expected, conflict, the onset of conflict is contributing about 26%, and followed by drought, population density, rainfall. So these are as we expect. So conflict is a leading cause of the displacement, followed by climate change variables. Okay, so now we trained the model. The next step is we test the performance, and the next step is to forecast and generate numbers. So for forecasting, it's usual. What you do is using the learned model MRF, you just predict. But when you predict, here the important thing is you provide new data set. Where you don't have output or even actual values. So X current is the current state of conflict, the current state of drought, the current state of settlement, and so on. Then you provide this information, and the model will give you the future state of displacement. This is how the setup is look like. So once you predicted, now you can do descriptive analysis. For instance, what is the number of displaced population in the coming 1 quarter? Then you can see in the coming quarter in Oromia, Somali, Amhara, and Tigray, there will be huge number of displacement. There would be expected number of displacement in these areas. So this is how you do map also the upcoming situation in the country. So as you can see, some parts of western part of the country and some parts of eastern areas are there are expected displacement to occur in the country. So this is how machine learning data science could contribute toward this forecasting, and also toward this decision making in humanitarian field. And now this model will going to be validated and improved, and we also welcome collaboration with organizations on this area. If you have detailed question, or if you would like to have more information on this, here is my email address, and let's dive into discussion with the available time. Thank you, everyone.
So we have just about 10 minutes. If there are any questions or comments, I don't see any in the chat, but I don't know if anyone just want to maybe unmute and take the floor.
Hi, can you hear me all?
Yes.
Right. Hi, this is Geoffrey Roquebert speaking from Zurich. I was curious about a couple of things about the presentation of Alexander. So, first of all, just a curiosity: is that a shiny dashboard that you did at the end? But that's not the actual question. The actual question is, I was curious when you said you were looking into more data sources for your model, and you mentioned satellite data. on one side, it's true that we do need more data because we're all modeling from the same, from exactly the same places. I mean, the ones who put the logos in there are the usual suspects. But we've been trying to include satellite in a lot of what we do, and there's a lot of. First of all, it requires strong partnerships because these are very expensive data. And second, we've been finding that there's a lot of instances in which it's very costly to operationalize the pictures into usable variables, and there's no obvious way to do this without engaging into another whole set of developing something that can extract it. It's not obvious how to go from satellite pictures into usable data in instances in which you're not going to see just obvious things, and you're not going to have to go into very expensive, tasking or anything like that. So yeah, do you have any ideas on that on that front?
Yeah, no, I think
Thank
that's
you.
a very good question. I mean, we have had some talks with a organization called Catapult, which looks a little bit into it, and I think some of the things that we have been contemplating has been around, there are these models where you can use sort of light to sort of assess livelihoods and the economic development in given areas based on sort of electricity and light at night. There are also more on sort of the environmental data and climate data, where we think there are some opportunities. But you're absolutely right that it is challenging, and where it's also beyond our own internal resources to be able to process that data and those images and actually get something meaningful out of it. So I fully agree that it's not sort of an easy fix to the data problem. And right now we are also working on building and seeing how far we can go on the subnational modeling without it. But maybe it will be able to complement it. But I agree, it's not an easy task. There was also a comment in the chat which I thought was quite interesting on a number of good comments actually now, but from Nasra Hussain, who asked if we face any ethical challenges. We actually, I think that was very important for us and something we worked a lot on. We actually initially worked on a model predicting mixed migration from Ethiopia, but decided partially due to ethical concerns to sort of to scrap that and focus more on forced displacement. Our concerns are, of course, that if this model ends up in the wrong hands, that it could potentially be used for closing borders. It could be used for sort of weaponizing it and using it to intensify conflict. I mean, with our model, you could potentially get a good idea of what you would need to do to displace a population. We try to avoid these elements, of course, by controlling the access to the model. For example, also when we forecast forced displacement, it includes both IDPs and refugees and asylum seekers. So we're not predicting whether they will be crossing borders. So definitely it is something we are constantly went into the design, but also something we're consistently monitoring and sort of evaluating what are the potential risks with this model. I don't know if you have anything, Jade, to add to that point.
Yeah, I think there are also specific questions, including the one that is how we addressed the limited number of observation in the data. This is an important question. So as you have seen, the observation we used is only 200 records per zonal level, admin 2 level, which is also which can be an issue, but displacement data is is challenging. One of the challenges to get displacement information from agencies. Even agencies are not even collecting enough information because of security reasons in those areas. For instance, in Ethiopia, it's highly insecure to collect this information from the war zone areas as well as from remote areas. So even if you get the access, the data might not be highly quality, and there is confidentiality issue, in providing data. So it's what it is. But what we can do is, when you do machine learning, you can somehow control the observation by making your data processing to generate more observation out of the data. For instance, you can do weekly estimates instead of monthly, or instead of quarterly. Instead of yearly, you can do monthly, where you can get 12 additional data or information. But you can also limit the number of features. So the number of features is important in terms of prediction. So it's not advisable to estimate using 200 records, another 200 features. So with proportional number of features and proportional number of rows, then that's going to be kind of useless. So as you can see, the number of features in our model is like about 9. So 9 to 200 is, I would say, is reasonable. And it is just our objective is to kind of develop prototype model, so that whenever the data set is increasing, access is increasing, then we can have more accurate prediction. And another question is about ethical issues. I think we have addressed this in one way or another. It is from our WAG, a person named Aude WAG. So we have issues of challenges of data, ethical issues to access the data, and machine learning is also it's not it's a kind of black box where we try to expose the inner working of the models by kind of trying to provide feature importances, as you saw in my presentation. For instance, what is the contribution of each variables in predicting the outcome. But all in all, again, it is difficult to kind of explain what's happening inside of the algorithms.
Good. I think we are on top of the hour. I can see that there are more questions, but I unfortunately think we have to close it down here. But again, you have our contact details if you want to reach out with any further questions that we were unable to address here, and of course if other questions come to mind as well. But thank you very much to everyone for participating and for the good questions and comments in the end.